Okay, for an object launched on Earth, the function h of t, that means h is a function of time. Really, you don't need that parentheses t. Get it out. Don't replace it with y. Keep it as h, but we don't need that. Equals vt minus 16t to the second. Okay, first off, I'm not a big fan of the way they wrote that. Remember, negative 16 is gravity. T to the second is like x a second. Usually we put that first. Okay, it's negative because of the minus, and then just put plus vt. I like it better like that. Models the height, I guess it doesn't really have to be rewritten, but that's fine. Models the height above surface of Earth. H feet, the initial velocity v feet per second, and the time t seconds since the object was launched, okay? Anika launched a model rocket with an initial velocity of 200 feet per second. What's the height in feet of the rocket 5 seconds after launch? Remember, negative 16 is gravity. We've mentioned that before. Okay, so I'm going to write that equation. Write it kind of small. They just have it a little different than what we did. Okay, so my variables are h, t, and v. Okay. Okay, well, 200 is your velocity, so that is your v value. And then 5 seconds, that's your time, because it says t seconds, so that's your t value. And then h was going to stay h. So h stays h, which is okay, because it's by itself, so it should be pretty easy. Negative 16 times, and we're going to put 5 in, 5 to the second. You could also go parentheses. And then v is 200. And then I come across t again, so it's 200 times 5. First thing we need to do is evaluate that exponent. 5 times 5 is 25, so this is replaced with 25. Okay, then we would multiply. Okay, these two we would multiply it. Okay, so negative 16 times 25, I believe that's negative 400, but I'll check to see. Yep. 200 times 5 is 1,000. Then I would just add those, and that's going to be 600 feet. Okay. Okay, let's do another one. For an object launched on Earth, the function, get that parentheses t. I hate that function notation crap. Equals vt minus 16t to the second. I want my negative t to the second to be written. I want it in standard form. Okay. So I just switch the order so that the second power term comes before the linear term. Models the height above the surface of Earth h feet. The initial velocity v feet per second and the time t seconds since the object was launched. Billy launched a model plane with an initial velocity of 400 feet per second. What's the height in feet of the plane 6 seconds after the launch? Okay. So h equals negative 16t to the second plus vt. Okay, h feet, well, they didn't give me that. That's not feet, that's feet per second. Okay, h is just feet, so we keep that as h. V, here's the variable v, feet per second, so that would be 400. So 400 is your v, and then the t is your seconds, so that would be 6 seconds. Okay, because you see it says v, or first it says h feet. Okay, we don't have feet. I know that you're like, well, that's feet. No, it's not. It's feet per second. Okay, feet is just overall feet without the per. We didn't know that. T seconds, so it'd be 6 for t. And then v, okay, feet per second, so the feet per second is 400. Okay, so h stays in variable form. T is 6 to the second, then v is 400, and t is 6. So we figure out the 6 to the second, that's 36. So it's negative 16 times 36 plus 400 times 6. Now we find our multiplication products. This is just essentially, please excuse my dear Aunt Sally, exponents, then the multiplication. Okay, I got negative 576. Then I find that product, it's 2,400. Okay, so I'd take negative 576 plus 2,400, that would give me 1,824 feet.